Okay, here it says birth weights full-term babies are approximately normal with a mean of 7.5 pounds and a standard deviation of 1.1 pounds. Okay, normal. And it says some physicians believe that a birth weight of 5.5 pounds or less is dangerous. And it says for a randomly selected full-term baby, what's the probability that the baby's weight is 5.5 pounds or less? So what's the probability that the weight of the baby is less than or equal to 5.5 pounds? So in this case, we draw our normal model. We're centered at 7.5. And we're going down to 5.5, and we want to know what's the probability of being 5.5 or less. So in this case, we know the answer for sure, whatever it is going to be less than 50%, just using some common sense. So we got to figure out our z-score. Our z is going to be 5.5 minus 7.5 divided by 1.1. So we get negative 2 on top divided by 1.1. I get negative 1.82, a z-score of negative 1.82, and I want to know what's the area to the left of negative 1.82. So I look up in the table. So from the table, the area to the left of negative 1.82 is equal to 0.0344. And that is our answer right here. That's going to be this answer. So about 3.44% of babies, of full-term babies, are 5.5 pounds or less. And then it says for a randomly selected full-term baby, what's the probability that the baby's birth weight is between 6.4 and 8.6 pounds? Okay, so we want to know between 6.4 and 8.6. We're centered at 7.5. I'm going to draw a cutoff line at 8.6 and draw a cutoff line at 6.4. Okay. And I need to find the area in between. So again, I've got to find the z-score for 8.6 and the z-score for 6.4. So the z-score for 8.6 minus 7.5 over 1.1, I get a z-score of positive 1, just 1.00. And the z-score for 6.4 minus 7.5 divided by 1.1, I get a z-score of negative 1.00. And we know that the area in between two regions is we take the area to the left of this one, and then we subtract off the smaller part. So if I look up area to the left, so this is very similar to 627. If I'm doing this part too quickly, watch the video for 627. It's very similar because we actually got the same z-scores. Z-scores of positive 1 and negative 1. So area to the left of z equals 1, that is equal to 0.8413. And then the area to the left of z equal to negative 1 is equal to 0.1587. And so the difference between 0.8413 minus 0.1587 is 0.6826. So the area in between, 0.6826. So that's just 0.8413 minus 0.1587 gives me 0.6826, about 68%. Okay. All right, and then the last part says if there were 600 full-term babies born at a hospital in 2010, how many of them would you expect to weigh 5.5 pounds or less? Okay, so I'm going to just erase this work right here. And this uses our answer from part A. We said 3.44% of babies are born are 5.5 pounds or less. Okay, so if we have 600 babies and we expect 3.44% of the 600 babies, we would just do 600 times 3.44%, which is 0.0344. So we expect 20.64. All right, so we expect about 20.64 babies to be 5.5 pounds or less. Now, of course, and when we actually counted how many babies were 5.5 pounds or less, we're gonna have a whole number of babies. Maybe we had 20 babies that were 5.5 pounds or less. Maybe we had 21, or maybe we had 22, or maybe we only had 18. Okay, what actually happened will not necessarily match this, but if we were just trying to make a prediction of what we expect, we would expect about 20.64 babies to be born 5.5 pounds or less.